Hello, today we're going to review a little bit about how to simplify complex numbers and answer quadratic equations where the solutions are complex. First, make sure if you haven't already, you jot your quadratic formula down because you may need it. So I'm going to go through a hypothetical warm-up because you're going to complete a warm-up that's going to be similar to the one that I am about to go through. So within it, it'll show you also how to answer some of the questions in terms of formatting. So our first question, solve by factoring, show all work. So here it is important to note that you need to show all work. So by that, what I want you to make sure you do is have the equation equal to 0. So this equation starts off that way. Show the factorization equal to 0. And then the solutions. So notice it's x equal solution, comma, space, solution. Okay, if you would like, you can also show this prior to your answer. That is fine. The more the merrier, but minimal. You need to show the factorization and solutions. Okay? Notice it is solved by factoring, so pay attention into what method you need to solve for as well. So make sure you are reading your directions carefully. Another question. Solve by factoring. Okay? Again, show all work. So again, when you see that, make sure that you adhere to that, because if you don't, your answers will be marked incorrect. So this equation, it's not equal to 0. So we have to subtract the 5. Now we can write the equation set equal to 0. So these are things that I need to see within showing your work. Then you need to factor. Okay, so we will multiply the 4 times 5 and get negative 20. So I'm looking at how I can multiply to get the negative 20 and add to get the negative 19. So my winner is 1 in 20 with a negative 20, a positive x. So I can expand. This part is optional, but I need to see the factorization equal to 0. So remember, once I expand, I have to chop it in half, and I can take out a 4x, and I'm left with x minus 5. I can take out a positive 1. I'm left with x minus 5. So this is how I know I've done something correct. So I need to see that factorization. So again, once I expand it, and I chop it in half, I'm taking the GCF out of this left side, which is 4x, which leaves me with x minus 5. There's nothing outside of 1 on the right side, so we factor out a positive 1, maintaining that x minus 5. So again, getting that common factor there lets me know I did something right, and then I put on my happy face to get my factorization of 4x plus 1, maintaining the x minus 5. And then show your solutions. So you need this, 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 and that, obviously, in terms of showing your work. Next question. We're going to simplify the square root of 27. Notice it says simplify, so we're not solving. So it's not anything equal to anything. No x equal to anything. Okay? So remember, you know your first 15 square roots of your perfect squares. Okay? These you should all know. Okay? And recognize, because that's going to make your life easy. That's the first 15. Okay? So, anytime you have a negative under the radical, you're going to pull I out. None of your answers will have a negative under the radical. I goes in front of radicals but behind integers. So for example, if I have the square root of 4, you know that that's 2. But if I have the square root of negative 4, that's 2i, with the radical, the I going behind the integer. If I have the square root of negative 12, we know that that's 4 times 3. So remember, we know that, so we can pull the 2i out and leave the square root of 3. So the I, again, will go behind integers, but in front of the radical sign. Okay? So the square root of 27, that's 9 times 3. We know the square root of 9 is 3, thus the 3i, leaving that 3 under the radical. Okay, so if it was just the square root of 9, negative 9, it would have just been 3i. So make sure, again, I goes behind integers, but in front of radicals. So if it was the square root of negative 5, it would just be I square root of 5. Okay, so quadratic formula is here to your right. So for these specific examples, our answers are going to be complex. So they're going to be in the form of A plus BI, with this being your real part and this obviously being imaginary because it includes the I, okay? So it may not be, this could be an integer, it could be fractional, either way, okay? So within these, we got to make sure we can identify A, B, and C. So remember, your equation has to be in the form of ax squared plus bx plus c. So if you look at this equation, you should realize A is 1, because there's no number shown here. B is positive 3, because it's plus 3. And C is 9. So from here, you would just plug and chug. So x is going to be equal to the opposite of b. So it's going to be negative 3 plus or minus the square root negative 3 squared minus 4 times 1 times positive 9 all over 2 times 1. So now we evaluate. Negative 3 plus or minus the square root of 9 minus 36 all over 2, which gives me negative 3 plus or minus the square root of negative 27 all over 2. So from here, much like we did on the previous problem, I have to simplify the square root of this negative 27. So x is equal to negative 3 plus or minus 3i square root of 3 over 2. So if I had to write it in an expanded form, I would just write x is equal to negative 3 minus 3i square root of 3 over 2, comma, negative 3 plus 3i square root of 3 all over 2. So when I go to type in my answers, it's going to look like so. You can leave it as the plus or minus, or if it indicates that you need to write it expanded, then you would do so. All right, another example here. So again, we're going to identify A as 1, B is -4 in this case, and C is again 9. So we're still going to plug and chug. So X is going to be equal to now the opposite of -4. It's going to be +4 plus or minus the square root of -4 squared minus 4 times 1 times 9. All over 4 times 1. So when we evaluate, we get 4 plus or minus the square root of 16 minus 36 all over 4, or 2 rather. And this should be 2 times 1, not 4 times 1. So here we get 4 plus or minus the square root of -20 over 2. So now we got to simplify that square root of -20. So 4 times 5 is 20. We add the negative. So we know we're pulling the I out. So we get 4 plus or minus 2i square root of 5 all over 2. So anything under the radical, it's safe, it's protected. We're no longer looking at it. But we have 2, 2, and 4. So we have a number that goes into all 3, which is 2. So that will become 2, 4 divided by 2, plus or minus 2 over 2 is 1. So that just becomes I square root of 5. So again, if you had to expand, 2 minus I square root of 5, comma, 2 plus I square root of 5. If it's something in Schoology, you can leave it with the plus or minus, but I know MathSpace likes for it to be expanded. So things to keep in mind. So make sure you get your work complete, and please let me know if you have any questions.